the teachers and PPD officers who are attending this Raspberry Pi webinar. On behalf of the Ministry of Education, Innovation and Talent Development Sarawak, I welcome and wish to thank all the participants. This webinar is a collaboration between MAITD and JPNS to introduce participants on the use of Raspberry Pi computers. As you all are aware, Sarawak government through MAITD had equipped every primary school in Sarawak on behalf of the Ministry of Education, Innovation and Talent Almost 10,000 units of Raspberry Pi computers were distributed to all 1,265 primary schools in the year This is an initiative to provide early exposure to ICT and foster digital literacy amongst our children from the It also provides our pupils at the primary school with basic computer knowledge to help in their secondary education, where a lot of schools note that most of them are either ICT teachers or teachers who are teaching the RVT subject, which means that you will be able to efficiently teachers. Today's webinar will give you all an opportunity to explore and discover the Raspberry Pi so that you have the necessary knowledge for you to study all the use it after this. Please take this opportunity to learn as much as possible from the trainers. Even though we are using online platform for this product knowledge training, do try your best to participate actively in the discussion. Of course, we will not just stop here. Raspberry Pi is more than just a regular desktop or laptop. Its open source nature makes it a perfect platform for pupils to learn programming skills and to start with coding hardware projects. Another advantage of Raspberry Pi is its Internet in a Box function that allows pupils to access to learning content or material preloaded in the device via an Internet network, which is useful for teachers to facilitate learning at school that do not have Internet access. This will provide a similar learning experience with those who have Internet facilities. I'm glad to inform you that a more comprehensive face-to-face training will be rolled out to every primary school starting next month, hopefully. This will be a 3-year project. You all will be trained to fully utilize the Raspberry Pi in your teaching and learning in class, as well as to foster innovation and digital skills among your pupils. This is also to ensure our pupils are better equipped and thus uplift the level of our education as a whole. As the saying goes, a journey of 1,000 miles begins with a single step. Here we are today in this first exploration and discovery with the Raspberry Pi webinar. I wish all of you a very successful and fruitful session. Thank you very much. Bye. Assalamualaikum dan salam sejahtera. Greeting to all the teachers and PPD.
Alright, good morning everyone. Thank you, Datuk. For the speech. He is the Permanent Secretary of Ministry of Education, Innovation and Talent Development. So, I'm Eileen from Karuna Sarawak. Welcome to the one-day exploration and discovery webinar. This webinar is brought to you by Karuna Sarawak, initiated by Ministry of Education, Innovation and Talent Development, with the support of Department of Education. I'm your host today and also your facilitator for today. Last but not least, I would also like to welcome everyone, all district officers and teachers to this webinar. So as a start for this webinar, please complete a webinar survey. So you may scan the QR code here to access the survey. Better right now? All right. Okay. Sorry about the disturbance just now. Are you able to hear me clearly right now? All right. Thank you, everyone. So please complete this pre-webinar survey so we can tailor this webinar more to your needs. The link is also sent to the chat room for your access. You may click in the link in the chat room or scan the QR code on the screen. Okay, so while you're doing some of you are still doing the pre-webinar survey, let us do some housekeeping. First of all, I would like to introduce you to the use of because I'm sure everyone is also very familiar with it already. So as an ice-breaking for today, let's tell me, how do you feel today? Are you excited for this event? Whenever we are, if you would like to ask any questions or you would like to talk, we encourage you to use the chat room so that we have less disturbance for the other participants. Then we can deliver this webinar more smoothly. Alright, the next thing I would like to do is the use of emojis. So you see that at the bottom of your Zoom, you see the actions button. Click on that and you'll be able to select the emoji that you like. Okay, so some of you are excited. Show me an emoji of how you think you look like today. All right, next we'll have another tool to be used together in this webinar. It's called Slido. For all the Q&As, we encourage you to submit it over here. You can scan the QR code or click on the link in the chat room. So you click on type your question here, and then you input your question. So if you would like us to email you personally later on your question, if it doesn't get answered because we have limited time, you can put your name in, your full name that you have registered, so we can email you personally on your questions. Other than that, in this Slido, you can also vote for the questions that other people ask that you are very interested in knowing the answer. And at the end of the webinar, we will be answering the top questions and as many questions as we can for the webinar. And for the questions that are unanswered, don't worry. We will also be compiling all the questions after the event into an FAQ and be sent out to the schools. So without further ado, let's start with the webinar. So of course, you are wondering why you are here. You are wondering why we need to learn Raspberry Pi, why we need to learn technology. So, and why do we need to incorporate this into the school curriculum? So we are moving into a digital society, and in conjunction with the initiative by the government to achieve Sarawak digital transformation by 2030, education is a key point to make this happen, and the students will be the builders for our community's future. So we want to let the students start young, and teachers, of course, you are the main facilitators to make this happen. So what are the contents of our webinar? Today, our webinar will be divided into 4 sections. First, we will look into what a Raspberry Pi is. Second, we will look into physical computing. Then we will look into digital making projects, some of the example projects that are created by Raspberry Pi Foundation. And also, we will look into how do you start with the curriculum in schools, right? So if I'm going too fast, let me know in the chat room. And if there are any technical terms that you don't understand, you can also type in the chat room, then I will answer to you on the spot. All right, so let's look, what is a Raspberry Pi? To know what a Raspberry Pi is and why the government is giving you Raspberry Pi as a teaching material or teaching tool, we need to look who built the Raspberry Pi. So the builders of the Raspberry Pi, very straightforward, is called the Raspberry Pi Foundation. They are a registered educational charity based in the UK, and their motivation is to advance education of adults and children, particularly in the field of computers, computer science, and all related subjects. Raspberry Pi also aims to provide low-cost, high-performance computers for people to learn, solve problems, and have fun. They want to make computer more relevant and accessible through outreach programs, help people learn through free educational resources and training. So why is it called a Raspberry Pi? First, at those days in the early computer companies were named after kinds of fruit. So you know about apple, that is one of them. So that's the reason why raspberry is in the picture. And then about Pi, Raspberry is initially built for Python, which is a programming language. So this Python programming language is actually commonly used for developing websites and software, and also for task automation, data analysis, and data visualization. And also we are also looking into today is that we can use Python to control electrical behavior. And despite that, even though initially they built it for Python programming, nowadays Raspberry Pi has evolved into a fully general purpose capable
Ada link tak? Kau dah ada link?
language.
Bagi kat email. Dia bagi kat email. Kita tengok email. Tak ada masuk.
Okay, all right. So let's continue on. What's so different from about Raspberry Pi from the normal PCs? Of course, I'm sure you have already seen it. It's very small in size, that's one thing. And also the construction of the Raspberry Pi. Your computer comes in a big form is because all your components inside the computer are actually connected through standard connection cables. While Raspberry Pi, everything is soldered onto the motherboard. That's why it can be so small, like the size of your palm hand. So all these are actually built on the motherboard, and then which means that upgrading your Raspberry Pi is almost like buying a new Raspberry Pi. You can't upgrade the hardware on the Raspberry Pi. You can only buy a new one if you want an upgraded Raspberry Pi. Another thing is that Raspberry Pi is also almost 10 times cheaper than the normal computers. So that's why it's good for training and teaching. Okay, and then the next thing is that we look into the connectivity of the Raspberry Pi. You can see that there are also less ports available, and some of the peripherals like the display, they are connected differently. We'll look into the Raspberry Pi mainboard later. Okay. And then the next thing we have is the memory. The memory, of course, in Raspberry Pi in a small computer, the read-write speed is slower and also the RAMs are smaller. But over the years, Raspberry Pi are trying to increase and improve in the processing power. So nowadays, we actually have 8 gig Raspberry Pis, 8 gig RAM Raspberry Pis. And of course, the storage is less because we are using SD card. But it's also very not sustainable, very flexible. You can change the memory card according to your needs. Okay, so let's take a look at a naked Raspberry Pi mainboard. Okay, okay, let me turn off my background. Wait a second. Right, so you can see here in my hand is a Raspberry Pi mainboard, a bare one. So what you have is actually the one that Master gave you is actually red, in the red and white box. This is the thing that is inside. So you can see here, these are the 40 pin general purpose output and input pins. This is for you to connect the hardware, the sensors, for you to interact with them. And then you see here you have the Wi-Fi and Bluetooth module. Okay, and then this thing here is for your display, for touch screen. And then you have the power over here. The new ones come in Type-C. There are older versions which comes in micro USB. Okay, and we have 2 display ports here for you to connect to 2 monitors, so you can have dual displays on Raspberry Pi nowadays. Last time is actually just a big one here, so you can only connect to 1 Raspberry Pi. So Master has already given you the newest one, which you can connect to 2 displays. Okay, and then we have the video and audio over here. Okay, the one at the bottom here. This is where you can put jack in your speakers, your headphones, and all your audio devices, and also for some of the camera video devices that comes with the 3mm jack. Okay, and then we have this one here. It's actually not the monitor. This one is for the camera. This is the camera module. So it goes into this port also and then processed by this one. And then what else do we have here? Okay, so this one is your processor here. You can see if you haven't started up your Raspberry Pi, you can actually open the white cover, but be careful because there's a fan attached to the mainboard, so don't open it too how to say, don't use too much strength to open it. Open it gently and slowly so you don't detach the fan. Okay, so you can see here inside the processor over here, and this one is the RAM. Okay, and then we'll look into some of the connection points. The first one here is the network connection, is for your internet. So you have a server unit which you need to connect to this port, to a router or a modem, to be able to get internet to your Raspberry Pi. Okay, and then you have the USB ports here that you can connect to connect your keyboard and mouse. Okay, and these are some of extra USB ports. So you can connect your mouse and keyboards anyhow over here. And also you can connect your hard disk, your pen drives, any USB devices over here. Okay, but your Raspberry Pi is a very small computer, so try not to overload it with too many connected devices. Okay, so let's take a look at the bottom. What's at the bottom? It's very simple. It's just one thing that you need to take note is the memory card slot. So if you turn over, you look at the bottom of your Raspberry Pi, the red color cover, you can see there's a black color card popping out. So that's your memory card. Okay, and so that is also where the memory card slot is. That's the only thing that is exposed out of the cover. Okay, and then, all right. So do you have any questions on the mainboard before I continue? Anything you want to know further? We'll be talking about more detailed things later. So it's better if you have any questions, you can clear out now on this. So the Raspberry Pi doesn't have a switch button. No, it doesn't have a switch button. Once you connect it to a power, it will just switch on. So we'll actually touch on this later, but I'll tell you first. You need to connect your display and everything else first, especially the display, before you turn on your power, or else your display will not work. Okay, so you have to connect the display first, then the power. Power always goes last. Okay, before you power it on, make sure everything is connected. Right. Anything else? If not, I'll go on to the next. We'll look into more how to set out a Raspberry Pi and how to power it up. Okay. So why use a Raspberry Pi? So we're talking about a lot of whys in the beginning. So in this era, computers are more accessible to the students. Why do we need to teach them computing? Why do we need to teach them like such a small computer? Looks like a very simple computer, but actually all these computers outside, it doesn't make the Raspberry Pi redundant. It's because they are actually closed, which means that the students, they have a closed exploration. It's a safe space for them to explore and learn. Raspberry Pi, they only comes with their they only support their compatible packages and apps only, which means you can't install very heavy games on the Raspberry Pi. You can only install the packages that the Raspberry Pi Foundation approved on the Raspberry Pi. And also Raspberry Pi is more towards on programming and coding. So on the other hand, Raspberry Pi is also open. It's open to the physical world. Using the normal PCs, you can't simply or easily connect to any other devices. You have to use the specific port. But on Raspberry Pi, because you have these pins here, you can easily connect to a lot of external devices and sensors. Okay? And then that's why you can control electrical control devices with the physical world. And so we want to let the students know they can actually use computer as a tool, not just for playing games, not for just doing their doing homework on Microsoft Word, but they can actually build and use their creativity in this. Another thing you might think, some of you might know about Arduino, and why don't we pick Arduino, we pick Raspberry Pi. So there's a magazine that says if you want to describe a project with one or no ends, you can use it with Arduino. It means that if you just want a simple project, simple electrical project, you can just use Arduino. But if you want to have more complex features with the hardware, the electricals, it's better to use Raspberry Pi. Right? So before we go on to the next topic, let's have a little bit of quiz here. Okay, what can the Chromium in Raspberry Pi access? That one we'll talk about it later. We'll touch on it on the fourth topic. All right. Okay, so first question here, let's revise a bit. What are the 6 aspects that differentiates Raspberry Pi from the normal PCs? You may type your answers in the chat box. The size, yes. Yeah, it's very obvious, it's the size. Yeah. Less storage. Oh, nice. Someone came out with the full answer. Construction, size, price, connectivity, memory, and storage. Correct. All right. So the second question. What are the components of Raspberry Pi? Name some. Who can name some of them? Touchscreen, the RAM, the internet port. That's what we call the network port. And also 2 HDMI ports, Type C. Type C, remember that's for powering up. The Bluetooth module, USB port. I think you guys have gotten it. Right, so let us move into topic number 2, physical computing. So we'll be getting more and more complicated throughout the webinar. So if you have any questions, you can type in the chat box or you can throw it onto Slido so we can answer to you later. All right. So physical computing. What's physical computing? We want to make cyber physical systems for everyone, not just people who are interested in computers. So technology, it can actually be blended into all areas of learning. It's not just typing on the computer, but you can also do it for science, for storytelling, for social studies, for foreign language, for technology, everything and anything else. Okay, so all these are actually very important part of all subjects in the students' education. There is audio in the Raspberry Pi. Yeah, I'll answer your question first. There's audio in the Raspberry Pi. This is the audio jack, where your audio jack goes. Okay. All right, so back to physical computing. Right. So we actually want the students, the young students, to have opportunity to not only learn technology, not only learn software programming, but we want them to also create technology for the future. Okay. Where's my slides moving? All right. Okay. Computer systems. So physical computing is actually computer systems that respond to the outside world, right? So we've been talking about that repeatedly. So let's get started a bit on how to set up your Raspberry Pi for physical computing. First, of course, the essentials. These are the basics that you need to have. You need a Raspberry Pi mainboard, you need a power supply, and a memory card. So when you buy a new Raspberry Pi, it only comes like this. Your box is actually an add-on. Master is very good. They pack it up in a box for you. So this is how a Raspberry Pi mainboard usually comes with. And then the power supply is Type C. So the power supply is also sold separately, but Master has already provided to you also. So the last thing also you need to buy separately usually is the memory card. But all these basics, Master has already packed up in the box for you, right? And then the next thing, of course, you need to have to operate the Raspberry Pi is a display, a mouse, and a keyboard, like your normal desktop. You need a mouse, a display, and a keyboard. Okay, and then you need to get ready the storage. How to get ready the storage? You need to plug in the micro SD card at the bottom, right? So be careful when you plug in the micro SD card. Be gentle. Don't break your micro SD because it is is very fragile. It's a small tiny piece of thing, and careful not to lose it because it's tight, but not extremely tight. There's no pin to pin it to secure it in place. So be careful with your micro SD card also, right? Okay, so how to get the device connected? You have your keyboard, your mouse. You can also use wireless USB mouse, right? And then you have your display over here. If you have a second display, you can connect over here. All right, so only after you connected this, you connect your power cord. Okay, so I'll repeat this a lot of times because it's very, very important to make sure your power cord is connected last, or else some peripherals, especially your display, it will not work. So sometimes when you plug in your power cord and then you plug in your display, you wonder why is my display not showing? It's because you didn't put in your display first. Okay, and then so this is a bit on the booting up. This is what you see when you start up your Raspberry Pi. So what are these? If you're curious enough, you see that there's a lot of things that is loading. It's actually the packages in the Raspberry Pi. Right? So Raspberry Pi actually shows you everything that's inside. That's why it's also a very good tool for learning. Okay, and then once it goes into this screen, it means that it's ready, it's been started up. Okay, then we look a bit on the desktop. I have a server unit here by master. Let me share the screen. All right, so you can see here on the top, your top bar, you have the Raspberry icon. This is the browser. So it's a Chromium browser. It works like Chrome. So just now someone asked what Chromium can browse. It's actually everything and anything as long you're connected to the internet and your Wi-Fi is good. But again, Raspberry Pi is a small computer. It's not meant for gaming, for very heavy items. So try not to load very heavy websites like some 3D games websites on the Raspberry Pi, or else your Raspberry Pi will get very jammed and you complain it, why is the computer lagging? The computer is actually not designed for such heavy stuff, right? And then you have the File Explorer. This is the terminal, which is like the command prompt on your Windows. Okay, so this Raspberry Pi icon is actually a menu, like the start menu on your Windows, your normal PC. So you can see all the available software that comes with Raspberry Pi. This one is preloaded with Raspberry Pi. So if you buy a Raspberry Pi, you come with this already. Okay. And then you have your settings, your preferences over here. Okay. Another thing we need to look at is the network connectivity. You see here the two arrows over here. If you're connected to the network, it will be there's two blue lines. But if you're not connected to the network, this is how it will look like. This is how it will look like if you're not connected to the network. There's two crosses over here, right? So one thing that you need to take note about, you have I believe you have two units that you have received from master. And then one of it is the server unit. The server unit, okay, you see there's only one Wi-Fi module over here. The server unit's Wi-Fi module has been occupied because your server unit acts like a router and like a router or modem that transmits Wi-Fi that other devices connected to it. So you can't use your server unit to connect to Wi-Fi. If you want to connect to the internet on your server unit, you need a cable to your network port. right? And then your on the other hand, your client unit, you can use Wi-Fi or network cable to connect to the internet, right? And then, all right, let's go on. If do you have any questions on this part? What is the maximum storage that you can install? It's the maximum storage size you can find for a micro SD memory card. So if your memory card, you can find a 128 gig memory card, you can install 128 gig for the Raspberry Pi. So it actually depends on what is in the market for the micro SD cards, right? So if you buy a new micro SD card, you want to replace the micro SD card that Master give you, you have to initialize the Raspberry Pi OS yourself. So there's a tool called Raspberry Pi Imager, something like this. It's a utility where you can load the Raspberry Pi operating system into the memory card, so you can use it for your Raspberry Pi. Okay. One of the Pi can't connect to the internet. The reason why it can't connect to the internet, I believe, is you can't connect it with Wi-Fi, correct? But if you connect the Pi, the network port, to your router, your internet router, you can get internet access to the Pi. All right. So yeah, a lot of you have mentioned you hope to get today's slides for your reference. After this, we will actually compile the recordings for all these webinar sessions. So don't worry, you'll get to watch the webinar later on also. You'll also be able to get the slides. All right. Okay, so any other questions before we move on into coding? You'll get more and more technical soon. Okay, no questions. All right, let's go on. Seems like everyone is catching up very nicely. Okay, go into coding. So after we get ready our Raspberry Pi, we can start working, right? So the first programming software that we want to introduce you to is Scratch. Why we want to introduce you to Scratch? Of course, it comes with the Raspberry Pi. It's free. And then you can see that it's actually a drag and drop programming. So there are actually predefined blocks here where you can drag and drop and then create your logic. So this is what we call block programming here. Okay, it's more focused on training the logical thinking and to encourage students to use their creativity to create solutions, simple solutions to solve problems. And it actually makes programming looks more fun because you don't have all the text, the very heavy text programming. And then, of course, there's also a lot of limitations to this simplicity. So the simpler it is, the more limitations there are. The more complicated it is, the more features you get to have. That's the contradictory over here. But of course, we want to start simple, right? So we start with Scratch because we want to get the students started with elementary programming first before we bog them out too much on complicated stuff, right? So next, we have a video to watch a bit on a simple project that is called Lost in Space. This is using Scratch. So if you have already booted up your Raspberry Pi, you can actually open up your Scratch and then follow the Lost in Space. So if you're wondering where can you find Scratch on your Raspberry Pi, you can click on this Raspberry Pi button. Oh, sorry. Okay. Click on this Raspberry Pi button, go to programming, and then you will find Scratch over here. Right? So I'll give you 30 seconds to open up your Scratch first, just in case you want. And then we'll go on
and watch the video. No, don't use Scratch free first. You use Scratch first. We start from the simplest one first. Later on, we will be trying out Scratch 3 also for more complicated features. If some of you, I'm not sure if you have received your Raspberry Pi, but what we are told is that Master has already given out the Raspberry Pi. So maybe I'll show you an example of what the Raspberry Pi that Master has distributed to you looks like. Let me get the example. Right. So, okay, on my screen here, you see this red and white color box. This is actually the Raspberry Pi that Master has distributed to you. Right? Okay. Right. So, okay. Let's go on. Let's watch how people create a program called Lost in Space. Sorry. Okay. I believe the music is turned off right now, right? Okay, so you see that it changes color as you execute the program. So the green flag up there is for you to run the program that you have already created. So you can adjust as you see fit. So this is where we want the students to put their creativity into achieving the goals that we set for them. Okay, so you can also customize your the media that you want and then put it onto the program. So there's also an image editor embedded inside the Scratch software. The Scratch app is loaded onto your Raspberry Pi. So you can see the Scratch app under programming when you click on the Raspberry Pi icon on the top left. Okay, so after you're done, you can save. Okay, and that's that's an example on how you can use Scratch to create some some animations or some creative projects. So you can actually set a goal for the students, ask them to imagine a scenario or maybe for your art class, you can use you can ask them to create a design or a program like this in using Scratch. Right. So it's the old version of Scratch app installed in the desktops there. I see. To get the latest Scratch app, okay, you can actually look at the Scratch tree later also. The Scratch tree is also able to achieve this, but we just don't want to go too fast into the newest one first. The Scratch is actually the first version of the Scratch app you see there without the number. It's actually the first version of Scratch, right? So, okay, do you have any questions on this before we move on? Any questions that you would like to know more about Scratch? You can also go to the Scratch website. It's called, you can Google Scratch and then let me copy the link for you. And you can see the source over there. You can also look for the latest version over there. So in the Scratch website, there are actually some starter projects you can look into for your teaching and learning experience in school. So you can try out some of the starter projects with your students also. Okay, so let us move on. We get into a little bit physical and then we have a little bit of quiz and then we'll have a break. All right. Okay, so let's get physical. All right. So first, before we get into physical, we look into what's actually involved in physical computing. Firstly, of course, the hardware. You can build a simple circuit with the Raspberry Pi. Let's say an LED circuit that we usually have in our RBT subjects, connecting the LED to the battery. That's one of the simple circuit that we can utilize. And then the second one is interfacing to control the output using Scratch. So we'll do a little bit of simple programming here to control our sensors or the hardware with Scratch, with simple programming. Okay, and then we will go on into more complex programming at the very end of it to create complex circuits with Python. So on the interfacing part, maybe you can only control the switch on, turn off, maybe some of the simple behaviors of the LED let's say we take LED circuit as an example. And then with the more complex circuits with Python, you can actually control more of the behaviors, let's say the blinking speed, the turning on and off speed, and so on. So you can actually control more when you use Python, right? So in a second. Okay, so there are actually some things in the market. Of course, this one is not provided by Master. It's actually an additional if you are interested, and when you think your students are ready to advance into more complex stuff, you can, or more advanced course, you can get this from the Citron website. It's actually an additional to the Raspberry Pi. So you can buy this to add on to the Raspberry Pi that Master has already given you, and then create some simple electrical projects. Why we recommend this is that this components inside this parts pack is actually simple electricals that are safe for learning. So you don't have to worry getting electrocuted. Okay, all right. So in RBT classes, you can also consider getting this. Again, this is an add-on to your Raspberry Pi. It's not provided by Master. You can consider this later to enhance your learning experience, right? So a bit on the Raspberry Pi, the parts pack, how it looks like when unpacked. So you have some jumper wires, the GPIO pin, which is the pins on your Raspberry Pi. This is the card where it guides you how to use it, and also you actually have that card. I'm not sure if your Raspberry Pi comes with it, but you can also actually Google for it. They have this pin layout card also. Sometimes they give this pin layout with your Raspberry Pi, so you can see that what each of the pins are for, right? So later we'll talk more about this. And then you have some sensors and some maybe some electrical components like the buzzer, the LED, and so on, right? So inside the parts pack, there are a few types of components. First are the components that have positives and negatives, which are the buzzer, LEDs, capacitor, and so these are the things that are polarized. They have the positive leg and also the negative leg. The positive leg is always longer. I'm sure you're very good at this if you teach RBT, right? So how much is the parts pack? All right, the parts pack costs I haven't checked it for quite a long time already. The parts pack, you can check it out on citron.io. So if you're interested to buy anything to add onto your Raspberry Pi to enhance your teaching experience, you can actually visit citron.io. That's where we usually buy our equipment for Raspberry Pi, okay? Okay, so okay, we'll go on first. Later, you can check out the price on Citron's website, okay? And then we have the resistors inside the parts pack, and you have the GPIO pins card. So this is the one that comes with your Raspberry Pi if you have it, right? So there are 3 types of pins on your Raspberry Pi, which are the special users pins. They have special purpose. The second one is the ones with special properties, and also general purpose. So I won't go too much detail into this. I don't want to complicate it too much for you at this stage. Later on, in the coming 2 to 3 years, you have a more in-depth and comprehensive course on this Raspberry Pi, the physical computing and the hardware projects and so on. Right? So don't get too nervous on this. Okay. And also remember the GPIO pins, they don't fall into order, means that they don't have a fixed pattern. So make sure you refer properly on the card which pin you are going to use. Okay. Okay. So another thing that we have inside the parts pack is the breadboard, right? So just now this one is actually a very ancient, the initial breadboard. Okay. And then this is the look of inside of the breadboard, right? This is of course the modern breadboard, the inside of the modern breadboard. Okay, so a breadboard is actually used for you to do electrical projects without having to do all the soldering and the connecting. You can actually just do a circuit, maybe a little bit complicated one on the breadboard. Then later we'll see a little bit of video on how to use a breadboard. So inside the breadboard, it actually looks like this. They have spring clips like this. Okay, so this is a spring clip. It has it's lined up inside the breadboard. So when you plug a cable in, it's actually plugged inside this clip. So be careful, don't plug something that is too big into the breadboard, or else it can bend the spring and then it will be loose. Then your cables, your small cables, won't be able to be held on anymore, right? Okay, and then we have the rails at the side. The rails are for more advanced circuits, right? And then so these lines of spring clips are actually called the bars. And then all these in the middle are actually rail lines where it acts as a brake, right? Okay, so you learn more of this later on in your 2 to 3 years course, right? Okay, we looked a bit on getting started on how to use a breadboard.
Hey guys, this video is all about breadboards, what they are, and
how you can use them when designing electronic circuits. So what is a breadboard? Well, here's the one that I use the most. A breadboard helps you build electronic circuits without actually soldering any components together. The breadboard is used to make the necessary connections between individual components. And if you make a mistake or if you want to change something, you can easily swap or move components around. So how do you actually use a breadboard? First of all, it is important to know that there are connections inside the breadboard itself that act like conducting wires. The holes, also known as connection points, are connected in groups of 5. This is what connects individual components together. So for example, if I wanted to connect a light bulb to a battery, I could create a circuit like so. The electrical connections inside the breadboard act as a wire and complete the circuit. I can also add a push button to the circuit like this. We can even get fancier by adding a variable resistor or a potentiometer to control the brightness of the light bulb. Just to be clear, while the connection points on the breadboard are electrically connected in groups of 5 like this, 2 adjacent groups are not connected. So if you hook up your components like this, you wouldn't have a complete circuit. How do you provide power to the breadboard? Most breadboard types have power rails. They let you connect a voltage source, such as a battery pack or a wall adapter, at one end of your breadboard and have easy access to power from any point. Some breadboards have a gap in the middle of the power rail, as indicated by the colored bands. The top and the bottom power rails may not be connected either, but you can use short jumper wires to connect them all. Speaking of wires, when working on a breadboard, do not use the kind of wires that have a dozen small conductors inside them. They just do not fit well inside the holes and make for a less reliable connection. Instead, you should use solid core wire.
So your jumper
You can buy several spools of wires of different colors and make your own jumper wires as long as you need them to be.
A very fixed wiring, it's not a hairy one like this one.
Or you can get a set of jumper wires that have pins at the ends meant to go inside a breadboard.
So instead of the very
How do you place components on a breadboard? That's actually easy. Just insert the metal leads of your parts firmly inside the connection points. Most electronic components will fit in just fine. But it is important to orient your components the right way. Remember that the holes inside the breadboard are connected in groups, so if I place an LED like so, it will never light up. Right now, its metal legs are practically bridged together and no electricity flows through the LED. Fortunately, since this is a breadboard, I can easily take out the LED and place it the right way. Now the circuit is complete and the LED lights up. If you are working with integrated circuits or chips, place them in the middle of your breadboard. That's what the gap in the middle is designed for. If you place them like this, you're basically creating a short circuit between the pins and your circuit isn't going to work. The connection points along the gap in the middle are not electrically connected, so you can use chips like this without blowing anything up. Now let's put theory into practice and build a simple LED circuit on our breadboard. I'm going to place the LED first and then build the circuit around it. Next, to limit the current that goes through the LED, I will add a 470 ohm resistor in series. Now I will add a push button also in series. Next, I connect the power source to my circuit and that's it. When I press the button, the LED lights up. And by now you already know enough about breadboards to start making cool circuits. Have fun and subscribe to my channel to never miss a video.
Alright, yeah, sorry about that just now. Some of you can't hear me while the video is talking. So the jumper wires, you can actually buy it separately if you want to buy the whole parts pack. The good thing about jumper wires is that their wires is not a hairy type. It's actually a one-piece wire. So you can easily plug into your breadboard or easily do connecting. So they have female and male terminals for the jumper wires. So when you buy, you need to be careful whether you want the female one, which is where you plug the male into, or you want a male one. So they have male to male, female to female, or male to female, right? So this is example of how a breadboard looks like. Okay, so a little bit of quiz time. I'm sure some of you knows how to use the annotation feature in Zoom. So now, okay, so now I want you to identify which one is a 3-volt pin on this GPIO card. You can annotate on my screen if you found the GPIO, not the GPIO, the 3-volt pin. Number 1, yes, correct. All right. So which one is the ground pin? Number 6. Anywhere else that has a ground pin? 14. Yes, correct. 25. 30. Yep. Okay, you pretty much got it. How about pin 17? Later you know why we need pin 17. Where's pin 17? What is pin 17 for? What type of pin is pin 17? 3-volt pin. Yes, correct. All right. So next, what holds the wire in a breadboard? What is the thing, the metal thing that holds the wire in the breadboard? Did anyone manage to catch it? A clip. What's that clip called? Spring clips, correct. Right. So this is before we go on a break, if you have any questions, can type in the chat room up till now.
Kulon sa bangan jam ya kamu school itu macam nak main kita di sekolah dah lo.
Right. If you don't have any questions, right? We'll have a 10 minutes break, right? For the slides, we'll be sending out together with the recording after the event, which means it's after the 5 sessions, right? So we'll be compiling the recording and the slides together to be sent out for you to refer later on.
Peniru ni menyalin semula apa kan? Apa itu? Macam kita nyebut nak biar.
Okay. Let's go. Okay, all right. So let's go on the 10 minutes break.
Macam kita dulu spelling test, ejaan.
So during this break time, if you have anything you want to ask, you can ask also in the chat room, and also do utilize the Slido that we have. So so we can compile the questions together into a FAQ for your reference later on also. The 5 sessions are the same content. So if you think you want to attend again later on, because you want to repeat or you want to revise, you can actually attend again. Just let us know. We'll send you the link. The Raspberry Pi is actually not a very powerful Raspberry Pi in the sense of the power that powers it up is only 5 volts. So it's not like the computer you need how much volts? I can't remember how much volts. Right. So the naturally the audio also is not that loud unless maybe you can use something to boost it up. This morning have attendance link. I'm not sure what you mean about attendance link. All right. During this break, if you would like to receive the FAQ, I will invite you to send me your email in the chat so we can compile and then send you the FAQ, or else the FAQ might only reach to your school but not to you personally, right? So if you would like to receive the FAQ personally, you can submit your emails in the chat room. Oh, the link for recording down your attendance today. Sorry, we don't have the link for that. Yeah. But if you registered with us, we do have your record that you are attending the webinar this morning. for those of you who are interested in attending the morning session tomorrow, we will send out the links for the sessions tomorrow by today, because we will only be closing the registration for the webinar tomorrow at noon today, right? So we'll be sending out the links in the afternoon. So if you want to join the sessions again, you can register for the session tomorrow and the day after tomorrow on the SAM website. And for those who were away just now, if you would like to receive the FAQ personally, you may send in your email over here, so we can directly blast the FAQ to you after the event. The topics and contents for the webinars of the 5 sessions are the same. So if you think you want to attend again, you can attend again, but the contents will still be the same. Okay, so what's the difference between a client and a server? A server is where you have the resources that your client can serve. So your client actually connects to your server to get the resources from the server. The client is the one that is consuming the resources from the server, right? So the server is the one that is holding and owning the resources. Why can't the Raspberry Pi print properly? The usual printers in the market usually are tailored more towards our normal PC, which is the Windows. So it's tailored more to the Windows. So some of the programming and the algorithms inside doesn't fit how the Raspberry Pi responds. So what we recommend for Raspberry Pi is that if you really want to print with the Raspberry Pi, you can get a simple printer, or you check the printer specs whether it's compatible with the Raspberry Pi. Yeah, because Raspberry Pi is actually more of a technical device, so it doesn't really do that much algorithm on the formatting and so on the printing part. Alright, so we'll start at 10 a.m. sharp. Do you need to attend all sessions? No, you don't need to attend all sessions. Only if you would like to attend again, you can register again on the website. Right? The registration for today's sessions are closed. You can register for the sessions tomorrow and the day after tomorrow. Why the projector can't show what is shown on the screen for your Raspberry? Right, the Raspberry Pi again is not very powerful in the sense of the voltage, the power. For the projectors, sometimes it requires a stronger signal to be able to display. So I've also tried before to connect Raspberry Pi to a display through a switch, a switch or a splitter. So that actually doesn't work. A Raspberry Pi can only support normal displays and also directly connected. The attendance link will be sent later. We have just created an attendance link. We'll send it out later together with the post-webinar survey. So stay tuned. We'll be sending the attendance link later.
Hello, good morning, admin. Hello, good morning.
Yes, good morning.
All right, I would like to ask for one question. Is it Google apps in like such as Google Drive? Is it considered as big? Because I've tried my colleague have tried to access the Google Drive using the Chromium inside the Raspberry Pi, but it still cannot be cannot accessible. Thank you.
You mean the Pi cannot access Google Drive?
Yes. Yeah, the Chromium.
You mean your own Google Drive or a shared folder?
Google Drive. The web-based Google Drive.
Okay, let me check on that. There are actually, some websites, it's not that it can't access, but I believe Google Drive should be able to be accessed. Or you mean a specific shared folder cannot be accessed?
The main page for the Google Drive.
The main page of Google Drive.
Yeah, drive.google.com. So we after
tried, it's able to access. Did you connect the Raspberry Pi to internet?
Yeah, I'm using the client connected with the Wi-Fi.
Oh, I see.
Yeah.
Why can't you not boot the Google Drive?
Yeah.
It could be an internet connection problem also, so it's quite hard to say. But I believe the Pi can also access the Google Drive should be able to access, because yeah, I've accessed the Google Drive also on the Raspberry Pi.
Okay, I will give it a try later on, and then I will give it to you later. Thank you.
No problem. All right, it's 10 a.m. Let's go on. Oh, all right. This is a message from Master. If you have any technical issues with your Raspberry Pi, you can contact Science Helpline. It's optional to attend all the sessions, because all the sessions are actually having the same contents. Right? So if you attend again later or tomorrow, it's actually you'll be actually hearing and seeing the same things. All right, let's go on. We'll be starting. We'll get into building things right now. Okay. I hope everyone is back. Okay. All right. So again, for those who are having technical issues with your Raspberry Pi, you can contact Science Helpline, which is attached to your Raspberry Pi unit. So the science technical team, they will help you to troubleshoot your Raspberry Pi. Right. So let's move on into building a simple circuit with Raspberry Pi, and we'll see how we can control it with Scratch 3. Okay. So this is actually a simple circuit here that we usually have in our current curriculums in school. We connect a battery to a LED, and maybe sometimes you have a resistor, but most of the times I believe we do not. And then with a switch, and then you control the on and off of the light with a switch. But now today we'll look into replacing the battery and also the switch with Raspberry Pi. So you can actually on and off the LED with a Raspberry Pi, and also power up the LED with a Raspberry Pi. Okay, so let's take a look on the demo doing a simple LED circuit with the Raspberry Pi. Right. So this is before that. This is also how you can turn a very familiar thing in your current curriculum, but a traditional one, into something that is modern with a Raspberry Pi. Okay. Right, so let's watch.
Okay, I'm going to show you how to turn this into this. What we're needing is one wire that has like these needle-like things on both ends. Two wires.
So what you see here is some of the
and an
jumper wires, an LED, and a resistor.
Breadboard and a Raspberry Pi. What I'm going to do is to connect the two wires from the Raspberry Pi to the breadboard. So first, get one of the wires and put it in this back slot.
Can you hear
two away from the left
audio?
So right there. And then this is the ground, right. So we're gonna connect this to the negative side. And now get the other wire, and you're gonna put it right here. Because this one right here is the 3.3
So now it's connecting the
which is how much you need to power an LED. And then you're going to put it in the positive side. We're gonna put the resistor. The resistor is important because if we don't put it, the LED was gonna explode because it's too much power. So we're gonna put the resistor. So one end is going to be in the negative, and the other could be anywhere inside the breadboard. So just like find a spot and then put it in. Now we're gonna put in our LED. So when you look at your LED, you notice that there's a longer side. The longer side has to face the positive.
You to
so when you put it, it's gonna be like this. The way power travels on the breadboard is that in this center-ish part, the power travels in a row like that. So we have to put it on the same row as the resistor like that. So make sure to put the longer end facing this way. Now we're gonna get the final wire and put this end anywhere in this row. So let's just put it like right there. And then get the other end and put it anywhere in the positive. And it'll light up.
Okay, so this is how you can replace a Raspberry Pi and not replace the Raspberry Pi. Replace a battery and a switch through the Raspberry Pi. All right. Okay. So do you have any questions on this part before we move on? We'll be starting to program a bit on program the circuit, do simple programming on the circuit. Okay, so next I'll also show you a video on how to control the LED with Scratch tree. So the video, I think it's showing Scratch too, but you can also it's also the same if you try it with Scratch tree, almost the same. Yeah.
Hi, my name's Ian Buckley, and you are watching.
Who have the Raspberry Pi with you? You can also try it together. Okay, it will show you how to download the libraries, additional libraries to do some additional features. Right? Let me make this full screen.
Hi, my name's Ian Buckley, and you are watching MakeUseOf.com. Today, we'll be making a start with Scratch, which is a visual programming language that comes bundled with the Raspberry desktop. We'll be using this to make a simple program which will react both to what we are doing on screen in terms of moving a character across the screen, and it will also turn an LED on and off, which we will attach to our GPIO pins. So to get started, let's set up the LED with our Raspberry Pi. So first we want to set up our Raspberry Pi. You'll notice that the power is not plugged in right now. That's always a good idea to not have it powered up when you're making your circuit, just in case you do something wrong and end up frying your Pi. All we're going to need today is 2 patch cables and one 220 ohm resistor. Although any other resistor value should work, your LED might not be as bright if you have a particularly high value. And then a normal red LED. So the way we're going to set this up is by just putting our LED into the breadboard to begin with. Now you want to make sure you know which side is the positive and which side is the negative side of your LED. You can usually tell because one of the legs will be slightly shorter than the other, and that is the negative side. But if you can't see that, if you look carefully at your LED, you can see on one side it is totally circular, and on the other side it has sort of a flat edge. And that's another way of telling if the LED is positive or negative on either side. So let's put it into our breadboard like this, with the positive side on the left here and the negative side on the right. And now we take our resistor, and we want to make sure that one of the legs of the resistor is in the same line in this direction as the positive line of the LED, and then the other leg can go in somewhere along here. There we go. Now, we also want to make sure that we can attach it to our Raspberry Pi, so we do that by attaching one of these cables to one leg of the resistor. This is the positive side, so this is going to go to our GPIO pin. And we take our other cable and attach it to the negative or ground side of our LED, and this one will be going to ground. So, exactly where are we going to plug these in today? Well, we want to use GPIO pin number 5. So if we look on our handy little chart here, we can see that GPIO pin number 5 is here, And that is, what, 6 or 7 pins in from the bottom? 1, 2, 3, 4, 5, 6. So if we count carefully, we can go 1, 2, 3, 4, 5, 6. And 2, 3, 4, 5, 6. Always count twice. And we can see from the same chart that if we want to plug it into ground, next to GPIO pin number 5 is a ground pin. So we can just stick our ground pin on this side of it. So have a quick check over once again, just to make sure that you've got all of these things in line. And once you're sure that all of these things are absolutely right and in place, take your power cord and boot up your Raspberry Pi. So to get started, we go to the Raspberry menu and look under Programming and select Scratch 2. And it will open up with the example project that is already there. Before we can get started with the Raspberry Pi though, we have to add a couple of things, because you can do a lot of great things with Scratch already, but to make the GPIO pins on the Raspberry Pi work, we need to navigate to More Blocks and add an extension and select pi.gpio. And what this will do is it will give us the option to set our GPIO pins to high and low. So let's look at how we'd make a program where you press a button and that changes the pin to high or low and turns our LED on or off. So to get started with our little program, let's drag our little cat over to the left side of the screen here and add something we can use as a button to click on. So down here in the sprites part of the screen, if you click this little face here, it'll allow you to choose a new sprite from their library. And I think this arrow looks good. So let's click OK, and it'll give us the arrow, which we can now drag up to the top of the screen. Now we want to start by making our blocks of code for our little cat. So make sure that you have the cat selected in the sprites menu just here. You can also just click on the cat itself. And you'll know if you have the right thing selected, because up in the top right here, it'll show a picture of a cat rather than the picture of the arrow. So what do we want to happen with our cat? Well, we want every time that this arrow is clicked, we'd like the cat to give us the arrow, which we can now drag up to the top of the screen. And we also want our GPIO pin, where we've already put our LED, to turn on. So in the More Blocks menu here, we can drag GPIO under Move 10 Steps, which means it'll be done just after the 10 steps have been moved. And in this little hole here, we want to select and enter the number of our GPIO pin. We had it set up today just on GPIO pin number 5, but if your GPIO pin is different, just have a look at your chart and make sure you put the right number in here. And once this has been turned on, we want it to stay on for just a short moment, and then we want it to turn off again. So if we look in the control menu, there is a thing here that says wait 1 second. That seems about the right amount of time. So we can clip that onto the bottom of our GPIO block here, go back to More Blocks, and drag the GPIO block out here. Once again, we want it to be the same pin, so GPIO number 5, but we want to set it to output low. Now, right now, this will only do something if we click on it and just tell it to do it. But what we want to happen is every time we click on our arrow, then it will carry this out. So if we now click on the arrow down here, we can use a different thing in here called an event in order to make this work. Specifically, we need to send a message. So every single time that this is clicked, we want it to send a message to our cat here. So we can use this block, which is when the sprite is clicked, it'll do whatever is beneath it. And we can also use broadcast, which will send a message out to everything with whatever we have written here. So we don't have to change it from message 1, but I am going to add a new message, which is go. So every single time this is clicked, it broadcasts the message go to everything else. Now, it's quite simple. We only have 2 things. So we can go back to our cat now. And on the same events menu, when it receives go, we can just put that on the top, which means every single time that the arrow sends the message go, the cat will receive it and move. And if you look down at your breadboard now, you should notice that every time you click this arrow, the LED will come on and turn off again after 1 second. So our program works now. When we press the button, he moves and the LED turns on or off. But what happens when our cat gets all the way over to this other side of the screen and we keep pressing the button? well, they go off the screen and there's not much we can do about it. So let's move them back to where they began and change our code so that every time the cat gets to the side of the screen, it automatically comes back to the start and the game can go on forever and ever and ever. So to do this, we need to look into our controls. What we need is if the cat hits the side of this screen, it needs to go back to the left side of the screen. So we use this if-then statement. We know we want to connect it to the bottom of our block here because we know we want to do it after it's moved and turned the light on or off. And after each one of these, if it is touching the edge, we want to send it back. So we use the sensing blocks to work this out. And the top one here says if it is touching. So we drag that into the little diamond shaped thing here. You'll know it's right because it glows when you put the mouse over it. And we want to change it from mouse pointer to edge. So if it is touching the edge of the screen at the end of this movement, it will do whatever is in here. So what do we want to do in here? Well, we want to move it. So let's look under the motion menu. And if you look, there is a go to here. So let's drag that into the block right here. And these values that are in here are actually where our character is already. So we don't need to change them. But let's say that you actually decided you wanted to start your character somewhere a little bit different. Let's say we wanted to put him a little bit further down here. Then what you can do is just put your mouse cursor over him and you'll see in the bottom right hand side of the screen here the values that you want to write down. So in this case it's -184 and -68. I'm going to put that in here just to make it slightly easier to remember. I'm actually going to say -185 and I've already forgotten the other one. It was -67. Let's just say -70. -70. So now, whenever it's touching the edge, it should move back over. So if we press our button, let's speed it up just a little bit. And we keep pressing our button. As soon as it hits the edge, it sends him back to the start so that we can keep going with this game forever. So this has been an introduction to using Scratch on the Raspberry Pi. There is a whole load of stuff you can do within Scratch. You can trigger sounds and you can use all kinds of different things with the GPIO blocks of your Raspberry Pi. You don't have to necessarily attach an LED. You could attach a servo to it so that every time you press the button, it would wave at you or something like that. Scratch is a really good way to learn the basics of coding. All of these different sensor points and control points that we looked into are the basics of coding itself, and learning it in this block form is a great way to get started. There is also a load of great resources for beginner coding on the Make Use Of website, and there is an article that goes along with this video. If any of it was a little fast or hard to follow, you can read that on the main website too. So thank you very much for watching today, folks. My name's Ian. You've been watching Make Use Of.
Right, so here you see how you can connect the LED to the GPIO pins, and then how you can program those pins to program your LED circuit. Right, so this is a very simple example of how to do a simple interface with the simple LED circuit. Right. So next we'll move on to a little bit more complicated, but don't be afraid. There will be a lot of time for you to learn in the upcoming 2 to 3 years course to train you on how to go into more advanced, starting from beginner. Elementary to advanced use of Raspberry Pi in your teaching and learning progress. Okay, yeah. So let's move on. We look a bit into Python. Okay. So this is a little sneak peek of how Python looks like. So in Raspberry Pi, the software that we use to program Python is called Thonny. So you can see up here, it's called Thonny. And in your Raspberry Pi also, you can use Thonny to program Python. So in Raspberry Pi, the software that we use to program Python is called Thonny. So you can see up here, it's called Thonny. And in your Raspberry Pi also, you can use Thonny to program Python. go to the Pi menu and then go into programming, and then you will see Tony Python IDE. So this is what you can use to program Pi, right? So regarding the app that's in the video just now, it's Scratch 2, but on your Pi, you're loaded with Scratch 3. That's the newer version of it, right? So you can actually achieve the same objective with Scratch 3, okay? Let's move on back to our slides. Okay, so here's a little bit of comparison between Scratch and Python. There are actually similarities between, which is the logical part. So you can see that once you are able to grasp the Scratch using block programming, you can actually translate it easier into text like Python, right? So why do we want to learn both Scratch and Python? And why do we learn Scratch first, then we learn Python? It's because we want to train the logical thinking with Scratch first, then after that, you go into more complex stuff, really do programming with Python, because logical thinking is a very important aspect in doing programming. So once they can grasp the logical thinking part, they are able to come up with a solution with Scratch independently. It's actually a very fast and very easy journey to learn Python also, right? So a little bit on the syntax of Python. What's a syntax? Syntax in layman terms is actually the format or grammar. So like in English, you have the grammar. So in Python or in any languages, there's also the grammar. The format for it is called syntax, right? So in programming, we usually have comments. So comments is for you to label your codes. Maybe you want to describe what this line of code is used for, so you use comment. So when you execute a program, a software, it doesn't take into consideration the comments. The comments is only for the ones who are developing to code, to understand what they are writing, right? Okay, so in Python, the comments usually start with a hash. Okay, so once you go to the next line, the hash is not effective anymore. It's actually a new line of code. So the next line, we actually have the import. Import is what we do to bring in pre-written module. A pre-written module is like just now you have in Scratch, you actually downloaded an extension library. So import actually lets you bring an external or an extension library into your program, right? And then, right, just now we talked about pin 17. Pin 17, in this project, you use pin 17 to connect your LED. So in Python, when you want to create an LED object, to use the LED on the pin 17, you have to create an LED object with pin 17, right? So usually inside the brackets, we call it parameters. So the parameters here is the pin, right? And then a loop. So if in any program, if you put while true, it means you want it to loop forever, right? So this is how you get to program an LED to turn to blink. So you turn on the LED and you tell it to sleep, and then it turns off and then it sleeps. So sleeping is actually like pausing for a while before it goes into the next action, right? So this is just a very simple, very short snippet of Python program. If you want to look more, Raspberry Pi also have the resources page on this Python programming. It's called Python Jumpstart. So you can scan this QR code to navigate to that website, or you can directly Google Python Jumpstart on Raspberry Pi resources page, right? Okay. So are there any questions before we move on? Okay. So in developing software or hardware, usually we need to visualize what our end product will look like first before we start to build. It actually helps us do our planning in building a project. So there's a method here where we call abstraction to help us build projects, right? Is to make very complex things, a whole circuit where you see the breadboard, all the wires are jumbled up. It's actually to simplify this into diagrams where you can see better visualize how your whole circuit or how your whole program works. Okay, so abstraction is to hide the unnecessary details. So when you see here, you see that that's my cursor. You see that the one on the right side is actually simpler compared to the one on the right side. So with the diagram on the right side, you know that this black wire is connected to ground. And then you have a resistor here. You have the LED and pin 17 connected. So from this raw image, we need to trace it by itself, pay more attention to know what's inside. But with abstraction and then with a schematic diagram like this, there's only lines and simple shapes to represent the components. So you get to see clearly at the first sight what is in your circuit, right? So there's also hardware abstraction. This is another way of simplifying your circuit. You can see that the whole block of traffic light is actually visualized on a simpler circuit on the breadboard with just LEDs and cables and the breadboard, right? And code abstraction. So this one is where we use built-in libraries or the extension library just now to simplify our code so it doesn't get too long. The longer it is, the harder it is to read. So we actually have built-in libraries like this one. LED is a built-in library, and then you get to use the library. Inside the libraries, there are other features to use also, right? So just now you see that there's a start, sleep, off, and sleep. Let me go back. This one, on, sleep, off, sleep. Okay, so all this is actually simplified into one line of code. LED dot blink. Okay, so this blink is actually a function inside the LED library. Okay, so here are some other examples of it. Okay, then next topic, we'll move on into digital making projects. So this is where the business gets more and more serious. We are going to look into building a whole full solution or full product, right? So this is what you can get at the advanced stage of your teaching and learning process. Okay, so there are a few projects that the Raspberry Pi Foundation did, and then they have a lot of examples on their website. Right, so later we are going to watch one example. But before we go into that, we look into some of the components that we will usually work with when we do digital making projects. Okay, So these are some of the simple things, more common ones that you work with: a button, a buzzer, a light sensor, a motion sensor, a temperature probe. These things, most of them you can find in the parts pack also. And of course, there are many more components that you can work with when you are doing digital making projects, right? So you can go onto the Raspberry Pi's website. You can scan this QR code to get into it. And then you can browse their projects, their digital making projects. They have a lot of them, right? You can pick, so yours would be Raspberry Pi. They have other types of machines. And you can filter what type of project you want, what type of software, what kind of levels even in the Raspberry Pi website, right? So let us move on, and we'll see how in this video there's actually a young learner involved. There's I think it's almost at elementary school level, and probably almost the same age as our primary school students. There's a coach with him, a facilitator, who is coaching him to create a robot buggy. So in here, not only we are watching how to build a robot buggy, but we are also seeing how the young learners and the facilitator comes together to learn together on how to build a digital making project, right? Okay, let's start.
Hi there, digital makers, and welcome to this week's Digital Making at Home from the Raspberry Pi Foundation. My name's Mark, and here's my sidekick Jimmy.
Hello.
And what we're going to be looking at this week is the theme of robotics. So what I thought I'd do in this video today is I would show you how to build your very own little robot buggy. This is all called physical computing. It's where we're going to use a Raspberry Pi to interact with things in the real world. And if we have time, we might even try and make it controllable by Android device as well, yeah, on your phone. So we might give that a go as well. So let's get started with this. I'm just going to change screens here and show you some of the kit that I've got here. So here we go. So what I've got here is this. Jim, what's this?
A Raspberry Pi.
That is a Raspberry Pi, right. Let's see if you can guess the other ones. Let's have a look at what are these.
Motors.
Motors, well done. What's this?
Battery.
That's a battery pack. Tricky one now, you ready? What's this thing called?
Screwdriver.
Yep, a screwdriver, well done. This, but don't suppose you'll know what this is called, will you? This is what's called a, I'll just put it under the camera there. This is a ball cast, yeah?
Okay.
Okay, and then finally I've got two different varieties of what are called motor controller boards, all right? So this is a really cheap little motor controller board. You can find them on things like Amazon and AliExpress. This one's a little bit more expensive, but we're going to use this motor controller board today, which is made by a company called Fortronics. And the reason we're going to use this one is because this one can attach directly straight onto the GPIO pins of your Raspberry Pi. Okay, whereas this one, we'd have to do some wiring up, so we'd have to use lots of little wires to get to it. Okay, so I'm just going to put this one away, but this is the one we're going to use today. So the first thing Jimmy and I are going to do is we're going to wire up the Raspberry Pi to the motor controller, and wire up all the motors and all the power. Okay, is that all right? Right, this takes a little bit of dexterity, so let's see what we can do, Jim. All right, so let's do the fiddly bit. The first thing we need to do is, because we're going to attach a hat to the Raspberry Pi, yeah, these things are called hats when they just sit on the pins. We're going to have to power off our Raspberry Pi. Okay, so I've got the Raspberry Pi at the moment. It's linked up via what we call VNC. You'll notice on the Raspberry Pi, I don't have a keyboard and mouse plugged in, and I don't have a monitor plugged in. Instead, what I did earlier is I went to Preferences on the Raspberry Pi menu here. So I go to Preferences and Raspberry Pi Configuration. Okay, and what I've done is in the Interfaces tab, I've just enabled VNC. Okay, and then on my Windows laptop that I'm on at the moment, I've downloaded this thing called VNC Viewer, and because I know the IP address of the Raspberry Pi, that means I can remote connect to it. So we're just going to shut down our Raspberry Pi to start off with, so that we can attach that hat. Okay, so go shut down. All right, and you can see my VNC connection has disappeared. All right, so my Raspberry Pi is shut down. All right, so just pull the power out of the Raspberry Pi, that USB-C connector there. Gone. Good hard tug, excellent. So we always power off our Pis before we place these hats on. So now you can place this hat on, so it goes this way round on those pins, yeah?
Okay.
Excellent, we're just going to make sure those pins are all lined up properly. No, back a bit more. There we go, and push on. Push quite hard. Excellent. Yeah, brilliant. That's perfect. Now the fiddly bit. So now we've got to put all our motors and stuff in. Okay, so let's just turn this like this. Okay. All right. Now then, we've got these 3 little terminal blocks here. 1, 2, 3. The middle one is going to be for power. All right, and the other 2 are for the motors. And I don't care which wire goes into which slot, because we're going to show a little trick later on so we can control all that code. All right. So what you need to do is place one wire into there and another into there. Can you see if you can do that?
What?
So that's it, a little bit down. There we go. And then, yeah, that's perfect. Now screw it on. So in the top, that's it. And then righty-tighty. Righty-tighty. That's it. Until it's really firm down. Yeah. Does that feel about as low as it can go? Yeah?
Yeah.
Okay, let's just have I'll do a little tiny tug like that. Okay, then what I'm going to do is we're going to place the rest of the motors in. Okay, so we've put our motors in, yeah?
Mm-hmm.
And we've also wired up our battery pack to that central terminal.
Yeah.
Now, what will happen is when it doesn't matter which way around the motors go, yeah? It doesn't matter which wire we put in which for the motors, but for the battery pack it is important. Okay, so the red wire is normally for what? You can take a guess, 50-50, positive or negative?
Positive.
Yeah,
Negative.
positive.
Oh, positive. Okay.
So that goes to V in. V in will be labelled on your motor controller board somewhere, and the black goes to ground. Okay, so that's important you get that the right way round. So now our motors are all set up. You'll notice, or you might be able to see on camera, that I've actually labelled the motors. So we've got an L on one, okay, and an R on the other. And now what we're going to do is we're going to do some coding. So what I need to do is I need to reconnect to the Raspberry Pi. Oh no, we need to power on the Raspberry Pi. So do you want to plug that into that USB-C port there? Okay. Brilliant. And then what I'm going to do is I'm going to wait for that to power up, and then we should be able to connect to it using VNC. Okay, so we have VNC loaded up, and Jimmy's going to drive the keyboard now. So if you want, Jimmy, could you go to the Raspberry Pi logo up at the top? That's it. And then just go to programming and then Mu. Mu doesn't come pre-installed on Raspberry Pi OS, but it is in the recommended software packages, so it's really easy to install. So the first thing we're going to do is we're going to import to the robot class from the GPIO 0 module, yeah? That's it.
So,
You'll notice that, that's it. You'll notice that Jimmy's using tab completion, which you've got in Mu, so you can press tab on certain keywords and it'll just auto-complete it for you. Good, so we've got our robot class. We need a name for our robot. What do you want to call it?
Rob.
Rob the robot. So Rob equals robot, that's it. And now we need to put in those pin numbers that the motor controller is connected to. Now for different motor controllers, the pins are going to be different numbers. The particular motor controller I've got here is sitting on the Raspberry Pi. Just move that over. I know that that one is connected to pins 7, 8, 9 and 10, okay, of the GPIO pins. But if you look at the documentation of the motor controller you've got, you'll be able to see what pins it's connected to. So let's get those pin numbers in. So in our robot, we need to open, that's it, 2 sets of brackets, 7, 8, close, good. And we need a comma between those two sets of brackets, that's it. 9 and 10, good, perfect. And then hit enter. And the command is
rob.forward.
Good. And then open close brackets at the end of that. Right then, now, if we run this now, go on, sorry, just save it as Rob the Robot. You've already got the save thing there, so just overwrite that one. That's it. That was our test one. Good. So we're going to switch on our thing. So hit run. That's it. Okay then. So our motors are going, yeah? And they're going to keep going for a long time. In fact, they're going to keep going forever. All right. So what we need to do is we need to put a stop command in there. All right. So underneath rob.forward, go rob.stop. Open close brackets. Now, what's the problem with this if we just run this now?
It'll go forward for like a second and then just stop.
Yeah. In fact, you're probably not even going to get to see it go forward. So what can we do?
I can add in a wait.
Yeah. What do we call that in Python?
A sleep.
Good. So what do we have to do to get the sleep?
So is it from sleep import sleep?
Close. It's from time.
Oh, okay, right.
Import sleep, and it's lowercase in this case. Good. Okay, and then we can put in a sleep for 5 seconds between rob.forward and rob.stop. That's it. Yep. Good. Let's run that and see whether that works. Oh, have I got the power on? So you run it first, so we can make sure that Rob stopped. We can see that the program's running at the bottom. And now I can see the little chevrons. See those little chevrons in the bottom corner?
Yeah.
That means that the program's finished running. So if I turn this on now, okay, and now run the program again, so stop and run. And our motors are going. 5 seconds. Right then, now we've got to figure out whether we've got these numbers, 7, 8, 9, 10 in the right order. Okay, so think about this. Here's my motors, and I've got the right and left I've labelled on them. All right then. Now, if these were sitting in a robot that's facing this way, facing the way the arrows are, which way do you think the L should move? Which direction should they spin? Should they spin
forward?
They should. If they spin forward, the wheels will be turning in that direction, won't they? Yeah, and the robot will go forward. So let's run the program again and see whether that motor is going forward. Is it?
It looks like it's going backwards.
It looks like it's going backwards. So let's have a play around with our code and see if we can fix that. So what I would do is, I'm not sure which one's which. I would change 7-8 to 8-7 and see whether that makes a difference. Perfect. And run again. They're going forwards now?
Yep.
Brilliant. Press stop. Okay, now, I didn't see which way the right one was going, so let's run it again. Both go in the right direction, yeah? Now we've got to check, though, whether we've got left and right correct. Okay, so stop the code. That's it, actually wait for... Stop and that's it, good. Okay, so let's just check. So instead of rob.forward, type rob.left. Okay, brilliant. Now just let's think about this a second before we run it. If it's turning left, yeah, which way round should the left wheels go? If you wanted the robot to turn this way, what should happen to those left wheels?
They shouldn't move.
They might not move, and just the right one go forward. What else could we do to make it turn sharper, though?
Move those ones backwards.
So if on robot.left, L should move backwards.
Okay.
So let's run.
Yep.
Brilliant. Okay, and stop it.
Oh wait, you have to.
Oh yeah. It'll stop after 5 seconds. It's fine. So we've got that, our left motor and our right motor is correct. What we could have done, if they were the wrong way round, we just swap these tuples around. So we put that one over this side and this one over that side. Okay. Right. What we need to do now is we've got our basic robot. Okay. What we're going to do now is we're going to stop recording for a little bit, and we are going to use this box here. Okay. That I've got. All right. I'm going to use this box to make my buggy. So what I'm going to do is inside the box, I'm going to place the motors, with the wheel, it's sticking out to the little axle sticking out, and I'm going to put some wheels on. Oh, I forgot to include wheels in our kit.
Should we record that start now?
No. What we'll do is I'll get some wheels out and I'll show everyone what it looks like. But yeah, you're also going to need some wheels for this project. Right, so let's stop recording for a bit and get this buggy built together, shall we?
Yeah.
Brilliant. All right, so Jimmy and I have now built the buggy. I'm going to show you what it looks like. So let's just switch over and have a look here. So what I've got is inside the box, I've put the 2 motors, and I've still got my Raspberry Pi and the little power pack there, and then the power lead still there. Okay, and then I push the axles of the motors through the side of the box on each side, so that I've got wheels. And then you might be able to see in here, down here, I've just put in a bit of wire, and all that's doing is it's threading through holes in the box to make sure that the motor doesn't shift and move around. So that's just holding that end of the motor down in place. All right, because when the robot starts to move backwards, if that wasn't there, then the motors would just lift up. All right then. So should we go back to your code, Jim, and have a look at, so it's the 4th one now. That's it. And have a look at how this works on the robot. Now, I will say, if we were doing this for real, okay, it's a really rubbish prototype, isn't it? Yeah. Okay, but it's going to work. If we were doing this for real, I'd be running the Raspberry Pi off a power pack rather than having it plugged in. But I can't find my power pack because I'm pretty sure Jimmy's lost it. So we're going to run it, it's still running off the mains, which means we're not going to be able to see the robot move around, but we'll still be able to see the wheels and everything move. So let's just place that like that. Okay then, so Jimmy, do you want to run your code and we'll be able to see the wheels turning? There we go. Just get 5 seconds and then it stops. All right then, so that's all working. Okay, and let's just run the code again and try and catch it before it falls off the table. Okay, so I'm just going to lift this camera up a little bit higher so you can see that there. Right, you're going to run the code and then catch it. Let's move that back. There we go, and it's turning. Right, and that's good. Now the other thing I would normally do, let's just get that back there. The other thing I would normally do is I take this this caster here and I would attach it to the front of the robot. All right, but we're not, because so this is like a third wheel that sits at the front. Yeah, let me just take it out of this plastic. There we go. So this is like a third wheel and it'll sit at the front, and it means that your robot can turn. But as we're not going to be driving this one around, we're just going to be showing you how to code it. Then I'm not going to put that on at the moment. All right then. So we did talk really briefly saying we might try and make a remote control for the robot. So should we show everyone how to do that?
Yep.
Cool. So let's get onto our code. So what we're going to do is we're going to get rid of that. Yep, brilliant. And then up underneath from time import sleep. In fact, we can get rid of from time import sleep now. We don't need that anymore.
Alright.
Okay, so we want from blue dot, all lowercase, and then import blue dot with a capital B and a capital D. Excellent. Okay, so blue dot is a Python library written by a very good friend of mine called Martin, who also works at the Raspberry Pi Foundation, and he has written this Python library, and he's also written an Android app that goes with it. I'm afraid it's not available on iPhones, it's Android only, this one. So I've installed the Blue Dot app from the Google Play Store. Just do a quick search for Blue Dot and you'll find it and install it onto your phone. And the other thing I've done is you might notice up in the top right hand corner of the screen there, that Bluetooth icon. You want to just give that a click. And what I've done is I've paired, if you look down at the bottom, there's my Android phone, okay, and it's paired. We don't need to connect to anything at the moment. Once I've paired it, yeah, Blue Dot will take care of the rest, so you can click off that. Right, so we need to set up our Blue Dot object. So BD equals Blue Dot, open brackets, close brackets. Capital, that's it.
Oh.
Open, close, excellent. And now what we're going to do is we're going to create a couple of functions. We're going to create a function called move, and that's going to handle the movement, and we're going to create a function called stop, which will make it all stop, okay? So if you enter a couple of times, and we'll go def move, and then open some brackets straight after move and type in pos. And what's going to happen is the Blue Dot library is going to pass in this thing called pos, which is going to be your position on the screen of the Android app, okay? So wherever your finger is, that's where pos will be. All right, so put a colon. You're going to yawn. Okay, and enter. Okay, so if pos dot top colon, so that's if our finger's at the top, enter. And then we want it to, so if our finger's at the top of the screen, which direction do we want to move it?
Forward, so
yeah,
so forward.
Rob dot forward, brilliant. Okay, if the pos is at the bottom,
should I just copy this?
Yeah, except you don't want to use an if, do you?
What do I want to use?
Else if, what's that in Python? elif, that's it. Elif pos dot bottom, enter, and then it's because you haven't put a colon at the end of your line. That's it, brilliant. Rob dot backwards. Now you can copy and paste if you want. So, that's it. And then if it's right, we want pos. If if the position is on the right, we want the robot to turn right. Oh, it's hot in here, isn't it?
Yeah.
It's a really sunny day in Lincolnshire today.
Why can't I not do that?
And then if it's left, then we want the robot to turn left. Brilliant, and hit enter. Okay, a couple of times. We like 2 line breaks between functions in Python. Yeah, don't have to, it's just like what we like to do. So we now do our stop function, def stop. Now we don't need to pass pos into this, so you can just open close brackets and put a colon, enter, and then what you're going to command the robot to do. Have you changed your robot's name all of a sudden?
Right.
Stop, open brackets, close brackets. Okay, and hit enter a couple of times again. Brilliant. And now we're just going to set up so that Blue Dot runs those functions. Okay, so what we want to say is bd dot when underscore pressed equals move. So that means that whenever it's pressed, it's going to call the move function. bd dot when moved equals, and then we're going to pass it the move function again. So that's if your finger, say your finger starts off at the top and then you move it to the bottom, yeah, it would go from being going forward to going backwards. And lastly, bd dot when released equals stop. So when you lift your finger off the blue dot, it should stop. Okay then. So what we're going to do is run that. Yep. Now you can see down at the bottom it says server started, yeah? So what it's doing at the moment is it's waiting for Blue Dot to connect. So let's see if you can see on my Android phone. There we go. And what I'm looking for is, I'm looking for the oh no, wrong one. Let's do that again. I'll have to turn it the right way around so I can do this. I'm looking for Raspberry Pi on here, so I'll click Raspberry Pi. And there we can see that big blue dot. Okay, now this is going to get tricky. So what I'm going to do is I'm going to hold the camera up. Let's go up a little bit higher with the camera. There we go. And then there's our robot. So Jimmy, just do one little push at the top. Good. And our robot goes forward, push at the back. Brilliant. Left and right. Excellent. And there we have it. Really, really simple way of remote controlling your robot using Blue Dot. Okay. Well done. That was excellent work. Let's just go back up to that. So that's it for today. As I said, you can find this.
All right, so I see some of you feel that it's really too much for a primary student, or it's really even too much for the teacher. But no worries, today, like our title says, it's actually just an exploration and discovery to show you what a Raspberry Pi can achieve, what you can do with a Raspberry Pi, and also what are some of the areas you can look into. So don't worry if you feel like, oh, there's too much today. Later we have a bit of light desserts, okay? This YouTube video is actually called Robot Buggy. You can search Robot Buggy with Raspberry Pi. Then you'll be able to find the digital making projects the Raspberry Pi Foundation has created. All right. So this, like you said, RBT maybe is only 1 hour a week. Yeah, it's impossible to do all these things. But actually, for this kind of big projects, you can actually think of breaking it down into smaller components, like how to connect. Like we start with how to operate a Raspberry Pi. With how do we connect? We set up, we start it up, we install the software that we need, and then we can slowly go into how to do coding in Scratch, then maybe separate it, and then go into like how to connect the electrical components. So you don't have to do the whole project in one lesson. You can actually break it down. So using a digital making project for your lessons, breaking it down into different small lessons, different components, can actually also help you make your lessons get interconnected. So the students can actually visualize how each of the components that you are teaching, each of the topics you are teaching, interconnect to each other, right? So don't worry too much on this. Later on, like we said just now, there will be 2 to 3 years course. So we are not expecting you to learn all this in one morning. That's impossible, right? So we'll move on. Let's have our little dessert, right? So we have an upcoming in-depth course, yes. But are we going to goyang kaki right now? Of course not. Master, the Raspberry Pi provided by Master has also come with preloaded materials that you can use for your teaching and learning process, right? So it's not too much on the technical part, but you can also use it, use this Raspberry Pi, utilize it for your teaching and learning process, starting from today, right? So inside there, it actually comes with a lot of preloaded teaching materials, videos, teacher guidebooks for you to use. Later, I'll show you a bit of it. So you have a server unit. So this server unit actually comes with what we call Internet in a box. So just now, like I said, this server unit, you can use it as an internet router. You just connect it to an internet, and then you get to you get to distribute the internet to all the connected clients, including your client unit, the Raspberry Pi. Okay. So when the client unit connects to this Raspberry Pi, your server unit actually comes with a server, a web server inside. where there are materials like the teacher's guidebook and the videos which are loaded inside, so you can browse it on the browser with Chromium. And if you are able to get your PC connected even to the server unit, your normal PC, your Windows PC, get it connected, you can also browse the materials inside, right? So don't necessarily have to get another second Raspberry Pi to use as a client. You can even use your PC if you are able to connect to it, right? So let me show you a bit of this on the actual one. So this is what you see when you start up your Raspberry Pi server unit. Okay, let me go into. So when you go into your Chromium, you want to go to the preloaded. You want to browse the preloaded materials that has been prepared by Master. You can go to bots.lan/home, right? bots.lan/home. Let me share this with you in the chat room. So in your Pi, you can browse this link, and then you'll be able to get to the Internet in the Box website in the Raspberry Pi. You can't access this through the internet. You can only access this when you connect your client PC or your client Raspberry Pi to the server Raspberry Pi, right? Because this is only preloaded inside the server unit. Okay, so you have a few things here. USB stick drive, you actually go back to the website itself. So there's a Wikipedia, local Wikipedia for you to use for schools, right? So this is somewhat like a Wikipedia. So it's filtered, and also the materials are selected for especially for schools use. Okay, and then we have Khan Academy inside. So this Khan Academy is actually a very popular platform which has a lot of materials for learning different topics, different areas, programming, from maths to programming. Even when I'm in secondary school, my teacher has introduced Khan Academy to us to learn maths. So there's actually a lot of materials from primary school, elementary school, secondary school, university, even in field work. There's a lot of things inside this Khan Academy. So you can go and browse this Khan Academy. And then you have this Media Wiki. You have the world maps. And then, yeah, this one, the last one that I'm talking about, but it's actually the one that we want to look into, is the e-learning part, where there's a lot of materials inside that Master has prepared for you. So if you have the username and password, you log in. So I'll just log in as the guest. And then you have, so once you connect, if you connect this server unit to the internet, this e-learning portal will get updated, right? When there's updates, of course, right? So there's announcements. You have science and maths guidebook for now. Then there's a lot of video webinars that you can have the sessions with your students. These are not technical webinars, don't worry. These are actually like maybe some of the storytelling, some like communication etiquette, some knowledge that the students need to know in their daily life, or even in their additional materials to their current study curriculum. Okay, so you can go on and browse. You go to bots.lan, and then you go into e-learning. Once you go into e-learning, you just log in, and then you can go into Master materials and browse all this, right? So you can take your time this time before you get to attend or participate in the 2 to 3 years program. You can explore all these first. These are actually already ready for you to use, right? Okay. So in Raspberry Pi, there's also one thing that is that you can use like your normal PC, which is something like Microsoft Office, but this is not Microsoft Office. It's actually an alternative to Microsoft Office. So in normal times, when you need to use Microsoft Office, but you don't have a PC with Microsoft Office, or you don't have a subscription, or your internet is not strong enough to update it, you can actually use the LibreOffice in Raspberry Pi. Right? So in Raspberry Pi, you have Word. It's called LibreWriter. Microsoft Word is called LibreWriter in Raspberry Pi. PowerPoint is called, okay, let's take a look. I can't really remember the names. All right, okay. So you can go to the Raspberry Pi menu, and then you see Office over here. So you get to see all this, right? So PowerPoint is called LibreOffice Impress, and your Microsoft Excel is called LibreOffice Calc, right? So these three, Calc, which is Calculate, Impress, and Writer, are the ones that you usually use in Microsoft Office. LibreOffice Base is actually the Microsoft Office Access for you to do database. And then you have Draw for you to draw flowcharts, and Math for you to do some calculations, formulas, equations inside, right? So you have very similar apps, Office apps in Raspberry Pi also. So you can actually also do your work inside here. The formats that it saves into is also compatible with Microsoft Office, so don't worry about that, right? Okay, before I move on into Q&A, are there any questions, or you can shoot it out to Slido? We'll review Slido right now and answer the top questions. All right. So while we are answering the questionnaires, the Q&As, you can also go to the post-webinar survey, and here I'll send you the attendance form. So you can sign in your attendance on this attendance link, and then okay. And also you can scan this QR to do the post-webinar survey, or click the link in the chat room, which will be sent in a while, to do the post-webinar survey. All right. So while you are doing the survey and filling up the attendance link, let me answer. Oh, right. Can add digital library internet in the box. We can put this into the feedback to master, right? So we'll take note on that and then give your feedback to master. Right. So the first question in Slido, can you explain further on server and client? How does it help the teacher? Right. How the server and client help the teacher? It's not really on how it helps the teacher, but it's the convenience it provides to you. The materials inside is loaded into one unit, which is called the server unit, and then you can actually use it to distribute out to everyone in especially those in rural areas. You don't have a good internet. Sometimes you need to go into the town to get better connection. So you can actually bring your server unit to the town area, connect it to the internet, download the materials, Then you can bring it back to the village and then distribute it by letting the other devices connect to the server unit through Wi-Fi to download the materials. So you only need one PC to download, and then you can distribute it out without internet. So that is how it helps you, especially in the rural areas. Okay. So I see a lot of hi and good morning. Good morning, everyone. We're almost lunchtime. Right. So this Raspberry Pi doesn't have a switch button. Yes, it doesn't have a switch button. Panel touch screen. That one, the panel touch screen. Where's my Raspberry Pi? All right. Okay. This is actually something. It's not for you to connect to. Wait. Yeah. It's actually a sensor. In how to say it, that complements the display parts. All right. Okay. And then, can we connect the Raspberry Pi to a printer? If the printer driver supports Raspberry Pi or Linux, so Raspberry Pi runs on Linux operating system. So if your printer supports, your printer's driver supports Linux operating system, then yes, you can connect it to the printer. But if it doesn't support, then you can't, right? So we usually recommend more on Raspberry Pi Foundation products because it's more for Raspberry Pi, because it's more tailored towards Raspberry Pi, and because Raspberry Pi is actually not a very commercial product, rather it's more on a learning and a charity tool. So it's not usually tailored, the commercialized products are not usually tailored to the Raspberry Pi. All right. Can you join all the webinar? Yes, of course, you are welcome to join all the webinar. You just need to register yourself on the website so we can send the link to you the day before the webinar, right? Okay. Server cannot connect with Wi-Fi, but others can. Yes, you should use a cable to connect your server to internet, because your server Wi-Fi unit, Wi-Fi module has been used for blasting out Wi-Fi signals to the other devices, so the other devices can connect to your server unit. That's why we call it a server unit, because it transmits Wi-Fi signals, so the others can connect to it. It's the Wi-Fi. So there's only one Wi-Fi module here, so it can only be used for one function. Either people connect to it, or it connects to the other devices. Yeah. So this one is actually pre-configured, right? Can we connect to the Raspberry Pi to the projector? It depends on how strong the signal the projector needs. Usually it's not really possible because the power source of Raspberry Pi is actually very low. The internet router has to be bought separately. The internet router usually comes with your internet subscription. If you have Unify, you get the Unify modem and a router. So you can just connect your server unit with a network cable to your router. Then you can get internet into your server unit. Okay. Can share the link boot image that have been given by master. Yeah, we can share we can request, give the feedback to master to share the boot image for Raspberry Pi, all right? Can connect to printer. Yes, if the printer driver supports Linux or Raspberry Pi OS, right? Which is the Debian OS, right? So you have to check with the printer provider whether they support or not. Okay, so what is the difference between a client and a server? That one is answered. Right, so connect to a Wi-Fi printer. That still is up to the printer provider, because even if it's a Wi-Fi printer, you still need the printer's driver to connect the Wi-Fi to print it to the printer. So there's an encoding, special encodings that the printers recognize that are usually programmed inside the drivers. Yes, whatever printer comes, so usually when you plug a printer into your PC, this is a bit out of topic, but I'll let you know. When you plug the printer into your PC, sometimes you don't need to install an additional driver because it automatically installs. So every time you plug a printer into your computer, it actually installs a driver. So if the driver is compatible with Raspberry Pi operating system, then the Raspberry Pi can use it. Sometimes you can, if it's like Canon or some reputable brands, you can actually go to their website, search for their printer, and then search for the printer driver. They will usually state what operating system is compatible with their printers. You can't find the printer in the list because usually when you can't find the printer in the list, it's because the driver is not installed. All right, so has everyone completed the survey? Should share more hands-on activity for us. No worries. In the 2 to 3 years in-depth course, you get to have a lot of hands-on activities. So stay tuned. Make time for it when the course comes. Right? For robotic purposes, do we have to dismantle the Raspberry Pi for the case? Yes and no. Actually, you can just open up the cover, then you can actually access to the GPIO pins already. So if you can access the GPIO pins, it's quite good enough already. So be careful when you detach the case. There's a small fan on top for heat, for releasing heat. So when you open up the case, you take note which pin the fan connects to. Then you can take off the cover. Then you can plug in the robot, the wires to the pins, right? If you were to use it as a normal computer, you have to dismantle your robot. If it's not a very complicated and you don't have to bring it anywhere else, you are still putting it in the same place, you don't have to dismantle your robot actually, as long as you can plug your keyboard, your display onto the Raspberry Pi, you can actually still use it as it is, even though you have your robot connected. Okay. Can we connect external drive and play movie on it? Yeah, but that's actually not the purpose for it. Yeah, but you can connect your external drive and play movie on it. Yeah. Right, so there's also a video player on the Raspberry Pi. Okay. Right, so do we have anything else? Right, if you have any more questions, you can actually also email us. Email me, elaine@karunasingapore.com, or you can go to our website, karuna.sarawak.com, go to contact us and submit your questions. You can also come to this Slido. We are still it's still open until end of the day. So we'll compile all the questions, compile and also filter the questions and into an FAQ for you to send it out after the event, right? All right, thank you everyone. Thank you for joining. And before everyone leaves, let's take about maintenance. All right. What about maintenance? What kind of maintenance are you looking into? If you say Raspberry Pi maintenance, for electricals, of course, the usual ones, don't overheat it. Sorry. Did I just end meeting for all? All right, okay. All right, so for electricals, usually don't overheat it, don't electrocute it. Yeah, it's just the basics, and take care of your Raspberry Pi. There's not much maintenance you need to do. Keep it inside the casing if you don't need it out of the casing. So because it's like, if you remove it from the casing, it's a naked box, like naked board like this. Okay, you can see my. Okay, so it's a naked board like this if you remove it from the case, which makes it very easily exposed to water, to dust. Even to dust can affect your electricals also. Water, dust, don't overheat it. And also don't scratch it, don't electrocute it. Yeah, so the basics, okay? Someone asked where you can buy a Raspberry Pi. You can go to citron.io to buy a Raspberry Pi. That's where we usually buy a Raspberry Pi. Okay? All right. I'm happy to see you all. Let's take a group photo, shall we? Right, teachers, open up your cameras. I know this is what you usually ask of your students in the past 2 years. All right. Okay, everyone ready? There are 4 pages. So hold your smile on my count of three. Hold your smile, and then I'll let you know when it's done. Right? One, two, three. Second page. One, two, three. For those who need to sign in on attendance links, you can access the attendance link just now to sign in. Right. So now we are on page 3. Page 4. My count of 3. 1, 2, 3. All right. So that's basically it for today. Thanks again, and have fun learning Raspberry Pi, and also have fun teaching Raspberry Pi. Right? Yep, we'll share the pictures with everyone after the event. You can stay tuned, and then we'll let you know where to view the pictures. Right? Goodbye, everyone.